Okay, Manohar, so let's start your snap mock for thermodynamics. And as you mentioned, you are preparing for GAIL India, GAIL India Limited,
Yes,
for
sir.
your campus placement offers. So
Yes,
my first question is to you, Manohar, what is thermodynamics?
sir, thermodynamics is a combination of two words. Thermo means energy, and dynamics means transformation. Energy has so many forms, and energy is so many forms, and it is classified on the basis of whether it can be
Achha, can
stored
you tell me
or
why the transformation is required, and what will happen to the total energy when we carry out the energy transformation?
So when we carry out transformation, one form of energy gets converted into another form of energy, like heat gets converted into work using heat engines, and work can be converted into heat using heat pump or some other devices.
No, try to make yourself visible if you can.
Sir, this my laptop is somewhat crashing, sir. And means websites are not opening, and
Okay, fine.
that's why if I'm
So,
clicking that is not opening.
take it. So, what happens to the total energy, Manohar, when we carry out energy transformation, and what will happen to the quality of energy when we carry out some kind of energy transformation?
Sorry, sir, I didn't get you. What happens if
Suppose
total energy?
we are carrying out some kind of energy transformation. Okay, it, you can take example of a
Okay.
motor, bulb, okay, kind of wind turbine, anything. So when we are carrying out some kind of energy transformation, energy conversion, so what happens to the total energy, and what happens to the available energy in that transformation process?
Sir, when some energy interactions are happening with the system, system uses its internal energy to do some work. So internal energy gets reduced, or if energy, if heat or anything supplied to the system, its internal energy gets increases. Or if any type of shaft work or any kind of work is done by system, then system's internal energy gets decreases.
What do you understand by a reversible process?
So reversible process is a theoretical process, and it is a very slow process, and we can call it as a quasi-static process without any energy losses due to friction or anything. That process can be reversed to the, I mean, sir, if a process is carried out from one state to another state, and we can reverse that process from state to final state to initial state again.
Can you give me some example of a reversible process?
Reversible process, constant volume process, or isobaric processes.
Are you sure constant
Practical
volume processes are reversible? Isobaric processes are reversible?
So they are polytropic processes, or if they carried out without energy loss, I mean, without any energy loss, it can be reversible. They are very slow processes.
What you heard about path function? No, path function.
Path function. So path function is it is a function in which it depends on paths, or when any if you take work, it is a path function because it depends on the path. It did not depends on the final state or initial state. It depends on the
So
path
work is a
followed
path
by the.
function. You want to say work is a path function.
Yes, sir.
What about internal energy?
It's a point function, sir.
Internal energy is point function.
Yes, sir.
What about Gibbs phase rule? Manohar?
Gibbs phase rule. Sorry, sir. I didn't study that. I do not have an idea.
What is first law of thermodynamics?
The first law of thermodynamics is conservation of energy, sir. In which means first law for a closed system will be whatever net heat given to the system. Mathematically, we can say that whatever net heat given to the system is equals to the change in internal energy of the system plus net work done by the system. It is for a closed system. And it basically tells that energy will not lost. Sir. One form get converted to another form only.
Energy is not going to lose. Like we are not going to lose energy.
Means energy one form gets converted to another form, but energy will not last. It says any process can happens, but energy form will get transmitted or changes.
What is thermodynamic temperature scale? What about thermodynamic temperature scale?
Thermodynamic temperature scale. So it is no idea.
What is Clausius inequality, Manohar? What is Clausius inequality?
Sir, Clausius inequality is cyclic integral dq by t is less than or equals to 0, sir. Yes, sir. Basically, it tells about the property called entropy.
Manohar, what are the reasons behind irreversibilities?
So the reason behind irreversibility is entropy generation, sir. Entropy generation.
Entropy generation is a kind of effect we are getting. Entropy generation is not the reason. Entropy generation is the final. Entropy generation is the effect we are observing. Manohar.
Okay.
Entropy generation is not the reason.
Irreversibility is because the available energy is getting destructed. So, we are losing energy because of loss of energy. Irreversibilities are happening. When we are
can you give me some of the practical application of this subject thermodynamics? Any area where you can utilize the knowledge of thermodynamics?
So we can use in power plants, and we can use it in energy production where where we use heat energy to get some useful energy.
So for a power plant, how you will define its first law efficiency and second law efficiency? For a typical thermal power plant, suppose a steam-based thermal power plant, how you will define its first law and second law efficiency?
So they in power plants they run on a cycle called the Rankine cycle, in which efficiency can be given as the energy efficiency can be given as the energy we get divided by the energy input, heat input. The heat input is given to the boiler, and we get energy from the turbine.
No, can we consider water vapor as an ideal gas?
No, sir.
We
can consider
yes.
We cannot consider as ideal gas, sir.
Cannot consider water vapor as an ideal gas.
Ideal gas, at low pressures and low temperature. So any real gas can be considered as ideal gas when the pressure is very low and the temperature is also low.
Temperature is also low. अच्छा, compressibility factor होता है मनोहर. You heard about compressibility factor?
Yes, sir.
क्या होता है?
So it tells the it tells how much we can compress a gas per unit change of pressure, sir. Means delta V by V divided by delta P.
ठीक है मनोहर. I think now I can provide you the feedback.
Okay.
मनोहर देखो, एक तो चीज क्या है पहली, like you are not looking confident. अपने कॉन्फिडेंस पे काम करो. Okay. You are looking like, you know, extra polite. It's looking like that. Your energy, your confidence is looking very low. So you need to work on that. Both are required.
Okay.
Technically, when you are delivering, okay, it's fine. It's not that much, you know, it's average actually when you are delivering. So your delivery style is okay. There is no such major problem with that. But yes, if you will have some more energy, more confidence in your delivery, I think then it will be much better. Let me come to the technical part. So I started with thermodynamics. What is thermodynamics? You mentioned about it's a combination of two words. So what typical answer है मनोहर? यहाँ से मत शुरू करो. Try to give some kind of answer from your own understanding of the subject. Thermodynamics क्या बताता है अपने को? तो बताओ ना कुछ ऐसा. सर thermodynamics बताता है कि sir, it tells us about the energy transformation. Thermodynamics is that branch of science which deals with energy transformation, sir, because we know energy we cannot create, we cannot destroy energy. So some kind of energy if you want, we need to carry out some kind of energy transformation. Energy को produce तो नहीं कर सकते, but what we can do, only we can convert one form of energy into another form. The entire aim of thermodynamics is to carry out that conversion more and more efficiently, so that loss will be less, the economy will be high. तो थोड़ा सा उसको बताओ. Yes, when you are answering, sir, it is thermo means heat, dynamics means some kind of power. So it's that branch of science which deals with conversion of interconversion of between heat and work. How we can carry out that conversion. तो थोड़ा सा इसमें कुछ अपनी अंडरस्टैंडिंग से बताने की कोशिश करनी है. So total energy constant रहता है. You cannot say कि sir energy remain conserved, energy remain constant, energy lose नहीं होगा. Total energy is going to remain constant. Like suppose you are converting work into heat. So when you are converting work into heat, so like suppose exit also at you are getting some small work, so work is going to decrease, heat is also going to decrease. But if you take net heat transfer equal to net work transfer, both are same.
Okay,
so total energy is going to remain constant. Total energy क्या रहेगी? Constant रहेगी. हो सकता है like one form of energy can decrease, another form can increase. Like suppose when you are using water, like suppose you are having a dam where you stored some kind of water. So what you are doing? You are utilizing the potential energy of the water and you are converting it into kinetic energy and you are producing the mechanical work. So potential energy is converting into kinetic energy and kinetic energy is finally converting into what? The mechanical energy, mechanical work.
Yes.
So total energy is going to remain constant. Like some part of the potential energy we are losing in the form of heat energy, pressure energy. So total energy क्या रहेगी आपकी? Conserved रहेगी. And available energy क्या करती है? हमेशा decrease करती है. In any real process, due to irreversibility in the system, the available energy is always going to decrease in a process, real process. Reversible के example बहुत सारे example आप दे सकते थे, like a frictionless motion of a object on a particular surface, electrolysis, isothermal compression expansion, constant volume आपको बोलना पड़ेगा उसमें, like volume constant, generally how you are defining a constant volume process. But constant volume से तो like there are so many processes which happens in a constant volume. So you cannot say, like, suppose you are having a gas inside a constant volume, you are supplying heat to that gas. That is not a constant. That is a constant volume process, but that process is not reversible. Are you ready? One idea. Constant volume, we cannot say constant volume is a reversible process always. So it is not the right answer. Isothermal compression, isothermal extension of a spring without any kind of hysteresis loss. Those are some of the examples for a reversible process. गिब्स फेज रूल आप भूल गए. गिब्स फेज रूल देखो आप.
Okay.
क्लोजेस्ट इनइक्वालिटी तो हमने बता दिया, बट अगेन यू मिस्ड थर्मोडायनामिक टेंपरेचर स्केल. सो दी 2-3 क्वेश्चंस तो आपने बिल्कुल ही मिस कर दिए थे. थर्मोडायनामिक टेंपरेचर स्केल, गिब्स फेज रूल.
Yes, sir.
Reason behind irreversibilities, there are two type of irreversibility, internal and external. Internal irreversibility is majorly due to friction, the conversion of heat into work. Okay, the work into heat, because when work is going to convert into heat, again the complete conversion of heat into work is not possible. Those are known as dissipation effect. It may be due to passes of current through a wire. Okay, it may be due to some kind of piston, some kind of paddle wheel work. So when work is converted into friction, that is known as dissipation effect. And when small amount of work converted into heat, the reversal of that heat into work is not possible. So that process is not a reversible process. That process will become irreversible. So dissipation effect, friction, these are the reason for internal irreversibility. External irreversibility is due to non-equilibrium between. Compressibility factor is a deviation, a factor which tells us about the deviation of a real gas from an ideal gas behavior. आप compressibility बता रहे थे. Compressibility में और compressibility factor में there is a huge difference. So compressibility factor is a factor which actually gives us the ratio of the specific volume of a gas to the specific volume of an ideal gas. And the compressibility factor is 1 for an ideal gas. And more is the deviation. Like suppose if you are having compressibility factor very, very low or very, very high, if it is not equal to 1, it means you are far away. The behavior of that gas is far away from the real gas behavior. Sorry, ideal gas. The real gas behavior is far away from the ideal gas behavior. You got the point, Manoj?
Yes, sir.
Compressibility is a factor which tells us about the deviation of a real gas from ideal gas behavior. ठीक है? चलो थोड़ा सा भी मेहनत करो, मनोहर. You are having time, so watch marathon class. Marathon class देख लो thermodynamics का. Listen to some of the subject snaps thermodynamics, and again you can go for another subject snap. ठीक है? कोई टेक्निकल डाउट आता है, एनी क्वेरी इफ यू फेस, यू कैन गेट बैक टू मी, यू कैन व्हाट्सएप मी और कॉल. ठीक है?
ओके सर.
ओके मनोहर, गुड लक एंड कीप प्रिपेयरिंग.
थैंक यू सर.
ठीक.